Alright, so now we're going to talk about multiplication properties, and there's a couple, but I want to kind of show you why this works at first. So we're used to this, and we know that that would be the same as 3 to the 4th would be the same as 3 times 3 times 3 times 3. And then we're taking that times 3 to the second, which is 3 times 3. And so then all together, I have 3 to the 6th power when I rewrite this as an exponent. Now, the easier thing is to notice that 4 plus 2 equals 6. And so that's the main reason why this works and all these others. So our product property, and I'm just going to use variables to represent that this could be any number. So if we have a to the m times a to the n. Now notice these are the same base. They're both a's. So as long as we have the same base, then we can add the exponents. So that would be the same as a to the m plus n. Again, has to be the same base. We can't do it if they're not the same base. Power to a power property, that's if I have a to the m to the n. So I have a power to a power. So my power is within a power. And when we have that, that is the same as I would multiply. Because whatever my power on the outside is that's how many times I am multiplying this by itself. So this would be the same as a to the m times n. So a to the m times n. And then we could have the power of a product property. And so that's when I have something like a times b, all of that to the mth power. And so what I'm going to do is I'm going to distribute this power between all my bases. So I would have a to the m, b to the m. And that works even if I have powers within here. I would just use the power of a product property with the power of a power property. So as you go along and we get further into powers, you're going to get into problems where you're going to have to use multiple properties or rules, whatever you want to call them. So here's our first examples. We're going to write the simplified form. So since these are the same base of 12, I'm going to do 12, and then it's going to be 4 plus 3. So that would be 12 to the 7th power. If it says evaluate, we would figure out what 12 to the 7th power is. Here we have a power to a power, right? 5 to the 4th to the 2nd power. And so here I'm going to multiply. So 5 to the 4 times 2, which is going to be 5 to the 8th power. And again, if it asked to evaluate, we would evaluate. But that's the basics of those two rules. This would be our product property, and then this one's our power to a power. Alright, so now algebraically, when we have variables in there, how does this work? Or a mix of variables and numbers. So on this first one, our bases that are the same are my z's. The z's are the bases that are the same. I'm going to take, because we're multiplying, I'm going to take 4 times 9. And then for my z's, because they are the same base, I'm going to do 5 plus the negative 12. Because when we're multiplying the same base, we will add our exponents. So 4 times 9 is going to give us 36. And then 5 plus the negative 12 is going to give us a negative 7. So we're going to have 36z to the negative 7. Now, this is not simplified because we have that negative exponent from that last video, and so my z to the negative 7 is going to move into the denominator. So we'll end up with 36 over z to the 7th power. And so then that will be our simplified form for the first one. Here, we just have that power to a power. So I'm going to do n to the 4 times 7. So we have n to the 28th power. And then on here, there's multiple ways I can do this. I have I have a product going on in here. So a power of products. I can do this one of two ways. I can distribute the -2 first and then move, or because this is the only negative, I'm going to go ahead and flip. So we would have 1 over 3g to the 4th squared. And so I'm going to go ahead and flip it first. And now I have all positive exponents. So from here, I'm just going to distribute to all. Now, this 3 has a power of 1. All bases, all numbers have powers. Even this 4 and 9, they had powers of 1. We just didn't need their powers to move on. This 3 has a power of 1. So we have 1 over 3 squared, because 1 times 2 is 3. And then g to the 8th, because 4 times 2 is 8. And then your last thing you should do is evaluate whatever parts you can evaluate. So we're going to have 1 over 3 squared is 9, g to the 8th power. And that is our final answer. All right, so then that is the end of our multiplication rules, and we'll just have your division rules next.